Hey, Miss Vides.
I am so sorry. I was having the worst time trying to connect because my other computer apparently doesn't want to turn on anymore. The one I keep at home.
Oh, because I know a lot of the students, some of us have like a little group chat,
Yeah, that's
and
good.
we realized that time was going. So I said I would stay
Yeah,
on,
and that's
but
the
a lot of
problem.
them left. Yeah, I can
Yeah,
let them know.
that's the problem. It's just I couldn't connect, so I was having the worst time. I was trying very hard, and I finally made it. I'm using my other laptop, so okay. Well, yeah. Thank you, Kennedy, for putting your name up there. Okay, so don't forget to do that. It's just my way of taking attendance, sort of kind of. And if the people that left, do you have a list of them that left so that I can put them in for Jean Marie?
Oh, you want me to put their names in the chat?
Yeah, do you? Yeah,
Okay, no problem.
please. Because the ones that I need to know, that they were here. I'll count them as being here since it is my fault. And not really my actual fault, but sort of my fault. Okay, there's one more person trying to come in. Hold on. Where are you? Oh man. Okay. Oh, there it goes. You. All right. And Gabrielle. It's I think I got everybody now. Yep. Yeah, that's 6 of you. Well, that's better than nothing. So, okay, so let's get started right away. Let's see. It should be sharing my screen. I don't know if I'm still in there yet or not because I was trying to get it in there. But I was also trying to log in at the same time. So probably no. Okay, there we go. All right. So we are going to continue the review that we were doing. So back down here to the test review right here. Okay. And we had completed most of it. Let me download this so I can get most of the first page or all of the first page for sure. Let's see. I think we stopped at 23. Am I right? Oh, that's too big. Oops. Nope. Nope. Let's make you smaller. Sorry. That's way too big. Can only read part of it. There we go. That's better. Ah, there we go. That's better. Okay. So let's go. Yeah, we did all of that. Yeah. Oh, 21. Yeah. 20. No, it wasn't 23. It was the density. We did the density, but we did not do this one. So it's 22. All right. For that one, that you can just do the chart that we were talking about. Remember the chart that we've been using where you just count or you divide, you subtract or whatever. Okay, so that's what we're going to do with this one, except we're going to actually fix it. So 177 milliliters. Why on earth did you get darker? Oh, I know why, because it's not plugged in. It is not plugged in and it is going to die. Sure enough. Yep. Okay, I'll be right back. I need to go get my charger because if I don't, it'll die. I've got the plug, so I just need to plug it in now. Here we go. All right. Sorry about that. I just was more trying to hurry up and connect than anything, and I forgot that maybe it might be low. All right. There we go. Now it's brighter. Okay, so 177 milliliters, and we are looking for the number. Okay, so you can do this times. I think I need to erase that because we were going to do the times, not this. Okay, so we're going to liters, right? So we don't need this actually. Erase. There we go. All right, so we're going to multiply times 10 to the negative 3, right? Because we're going from milliliters to liters. So remember, we need to move back 2. So 1, 2 backwards. That means we're decreasing. So we increase by 2. And we get 1.77 times 10 to the negative 1. And that would be liters. Okay, and that's that. Can you guys hear me okay? Yeah. Okay, so that's that first one. Okay. All right, so I'm going to erase that one and keep going. All right, let's clear all drawings and go to the next one. So the next one's 56 meters to centimeters. Again, decrease by 1, increase by 1, right? So we got 5.6 times 10 to the third centimeters. That's that one. That's number 23. Okay. Clear that one. Okay, you guys copying these. All right, let's clear that one. Then go next one is 0.093 kilograms times 10 to the 6 milligrams. Okay, so this time we need to increase. So 1, 2, and decrease by 2. So it's 9.3 times 10 to the 4th milligrams. You see that? Why on earth is it going up and down? This is weird. Okay, so let's go to next one. So far we've done 1, 2, 3, 25 is the next one. Okay, so we're going to do 54,400, and that is micrometers. So micrometers, we want to change to decimeters. So micro to deci is 10 to the 5th, So let's clear that, but it would be -5 because we're going up, right? So times 10, oops, wrong one. Sorry about that. No, I went the skinny one, times 10 to the -5. Yes, and that would be decimeters. Now, again, we need to go back 1, 2, 3, 4. So if we go back 4, we increase this one by 4, right? It's 5.44 times 10 to the -1 decimeters. You see that? So far, you're keeping up? Everybody okay? Yeah? Oh, I'm sorry. Sorry about that. I didn't see you in the waiting room. Okay. All right. I didn't see you guys in the waiting room. Sorry about that. I had to go grab my charger for the computer, my cord, and I guess you must have come in right when I did that. Okay. Anyway, so we're doing 25 right now. This is the next one right here. All right, so we are going to do 26. Let's clear all these drawings. And that is terameters. Let's see. 1500 terameters. And we're going to hecta. I have to have that one is the one where I need my own little thing because six, no, well, we're going to hectometers, okay. Okay, so we're going from tera to hecta. We're going down, so that is times 10 to the 10, right? Excuse me. And that is hectometers, but again, we cannot use this. Sorry, they would take this off. Okay. Because we need to decrease it. So we need to go back 1, 2, 3, right? Decrease it by 3, increase it by 3. So that is 1.5, and that's a period. It's just periods are hard to do with your fingers. Times 10 to the 13th hectometers. There you go. That's that one. All right. Let me clear that. And go up a little bit so that you can see the rest of them. All right, yeah, there we go. Cool. Okay, so we're doing 27 now, which is 0.04 seconds to nanoseconds. And 1 second is equal to 10 to the 9th nanoseconds, right? So we need to erase this one out. Okay, so now we need to increase 1, 2, and decrease this one by 2. So it is 4 times 10 to the 7th nanoseconds. Okay. Everything so far so good. Remember, all you were doing is counting or subtracting, adding, whatever the exponents. In this case, the 10 to the 9th is direct because it's from 0 to 9, right? All right, let's go. And we're going down, so it's positive. Now, the next one is deciliters to megaliters. That's a big one. Okay, so it's 132.6 times 10 to the what? Okay, so deciliters is 10 to the -1. Remember how we do that? and megaliters is 10 to the 6, if I'm not mistaken. Yeah. Okay. So if they're opposite, you add, remember? So this is to the 7th. Okay. And now we're going up, so it's negative. You see that? All right. So we're going to 1, 2 backwards. So we're decreasing by 2. So we need to increase by 2. And then the answer is 1.326 times 10 to the negative 5. And that would be megaliters. Okay. There you go. That's how you do the conversions in a fast way with the way that I showed you with the exponents that I gave you. And you can use those, like I said, but you eventually, if you ever have to memorize them, I gave you that mnemonic device that you can use too. All right, that's 28. I think that's all of those. Let me see. Yeah. Okay. Now this one, and I want you guys to participate with this one, please. All right. So you're looking at 2 images, right? You can see them pretty well. You see an image A that has, and it says you need to determine whether they are accurate, precise, or both, and explain why. Okay, so who wants to do A? Just go ahead and unmute yourself and go for it. Okay. Go ahead. Who wants to do it? Accurate, precise, or both? And why? We went over these. Okay. So the purpose of this game is to hit the red part, right? In this case, they didn't. So accurate, it is not. But they are pretty much bunched up. So I would say they are definitely precise because of the fact that they are close to each other. Okay. And then the other one is in the middle, and they are pretty much bunched up too. So this one is both because it did hit the target where it needed to. And secondly, they are very much repeatable. So whoever was shooting these 5 little darts ended up in the right place. Okay. All right, so that's those. Let's go to the next one. All right, this is the one where we are going to have to put in I'm going to insert the tables. Okay, so I'm going to insert a table right here with, come on, table. Why are you not giving me the table? Oh, sometimes this is annoying. Sorry, but I need to, there it goes. It's inserting the tables, it's just slow. I want to put in a table that goes from, I think 2, currently disabled. Why? Oh, no. No, don't do that. Okay. Oh, because it is in protected view. That's why I forgot to tell it to. Okay. That's the problem. Okay. That's the problem right there. I needed to not enable editing. There we go. Now I can do it. All right. So we are going to go back. All right. So in this case, I'm going to do it, like I said, by inserting a table where I want it here. Okay. So insert. I'm going to insert a 2x4. That's what I've been doing all along. Okay, so on the first one, remember, you put what you know. So it's 1.5 kilometers, right? That's what we know. You notice it says, how many steps does he take if every step he takes is equal to 2.25 feet? All right, so we know that there's a conversion factor. And if you look at our, hold on, let me go escape here. I need to go back to where we were on our Moodle. I mean, not Moodle, sorry, not Moodle. That's not you. On our Canvas. Okay, so right here, we have used these tables before. Okay, so we have a conversion chart that is metric system. Let's see, where are you? Conversion chart. I'm not seeing it. Hold on, I'm looking for it. Metric to English. That's the one we want. Okay, so we're going to download that one so we can look at it. All right, and there it is right there. Length. Okay, we have 1 meter equals to centimeters. Do we have a kilometer? Yeah. Miles to yards. We don't have miles. So what do we need? We have kilometers. So we need kilometers to meters. And then meters to feet. There we go. 5,280 feet. You see that right here? I'm going to actually highlight it, spotlight it for you so you can see it right here on this area right here. Hold on. Where's my spotlight? It went away. Oh, come on, spotlight. There we go. Right here. See it right there? 1 mile. 1 mile equals this many feet, but 1 meter equals that many yards. And then you can go 1 meters equal this many feet right there. So we want feet and we have kilometers. So we're going to change it to kilometers first and then to feet, 3.28 feet. Remember that number. All right, so we're now going to switch back to where we were and look at it. Okay, where are we? I need to bring this down. Okay. Go back to not there. I need to go back to where we were here. Oh, stop doing that. Sorry. It's just I need to get to my word. There we go. All right. So 1.5 kilometers. So we are first going to change 1 kilometer to meters. So we know that that is 1 times 10 to the third meters. And I'm just going to put this up. Okay, so where are you? I can pull it up. There we go. Oops, come on. Super. It's not doing it. Why? Oh, I know why. Because I don't have the mouse. I have this. Okay, now I got it. All right, superscript there. Okay. And then we had meters. Remember what it was? 1 meter was equal to 3.28 feet, right? Okay. So that took us to where we wanted in feet, but then we still have this other thing that says each step is equal to 2.25 feet. So 2.25 feet is equal to 1 step. And that is what we want to know, right? Is how many steps. Okay, so if you multiply the top divided by what's on the bottom, you should get the answer. Okay, so let's go. It's 1.5 times 1 times 10 to the third times 3.28 equals, and then divided by 2.25. And the answer is this right here. I'm going to type it in. It is 2186.66, you know, however, 667, I'll just put it there. And that would be steps. Okay, so, steps. All right, but we started with 2 sig figs, so we need to only keep 2. So the answer is 2,200 steps. And there you go. So that's how you do these. You have to look at all that's in there, what's required to make the path. Usually what I will do is I will create a path and it'll say kilometers based on what I have to kilometers, to, in this case, we had meters. And then meters will go to feet because that's what we had. Then feet, we were given the step equivalent, so to step. And you notice that everything that is on the top, is in this pathway that I created. Kilometers to meters to feet to step. And then all you have to do after that is think about where I'm coming from, where I want to go. See, so this is where I'm coming from. Where I want to go is on the top. And then where you were coming from needs to be on the bottom. So again, where I'm coming from is meters. But I need to get to feet, right? So now it's where I'm going to is feet. Where I'm coming from is meters. So meters goes on the bottom. Again, feet is where I'm coming from now. So feet goes on the bottom. And where I'm going to is step. You see how each time? Okay. All right, so let's do this next one the same way. We're going to insert another table with 4 by 2. Yep. Oh, not 3. Okay, well, I can just remove 1 easily. All of it. Not. And the entire row, yes. Okay. There we go. All right, and where are we starting? We know we are starting with 5.5 feet because that's what we were told. 5.50 feet. What is her height in centimeters? Well, let's go back and look at our chart and see, is there feet to centimeter in here? We do not happen to have one of those. Okay, so what do? We need to say, oh, there's feet to meters, and then we can change it to centimeters, right? Okay, let's do that. All right, let's go back. Okay, so we said we had 3.28 feet for 1 meter, right? Remember, that's where we're going to is meters. And then we're going to change it from meters. So meters needs to go on the bottom to centimeters, which goes on the top, which is 1 times 10 to the second. Or if you want to call it 100, that's also okay. Okay, hold on. Where's my mouse is not working for some reason. Nope. Okay, maybe I'm not with mouse. Nope, I am with mouse. What in the world? There we go. All right, and we need to put that as, there we go. And that would be centimeters, right? So just write that down here. Take this off of being up here and centimeters. Okay, so that's exactly what we've done here. So again, multiply what's on top. So it would be 5.50 times 10 to the second equals, and then divided by 3.28. And her height in centimeters is equal to 168. Okay, why 168? Okay, so my answer is 167.68. Okay, but again, we need to change that to the right sig figs, which we only had 3, so it's 168. There you go. See? And that path, which I didn't create, would have been feet. We said to centimeters. I don't know why I put capital, but that's all right. and then to, oh no, sorry, to meters. To meters, and then to centimeters. There we go. So each time that you are doing one of these, I suggest that you create a path first, that you know where to go, and then from there you look for the equivalences, and it's much easier for you to do. All right, look at this next one. This next one says, how many milliliters? Okay, so let's do the path. Milliliters are in a 20, nope, that's not what we're going. Okay, we have ounces first, right? So ounces first. And then we've got, that's our first question, ounces. It says there are 32 ounces in a quart. So we are going to go from ounces to quarts. And then quarts, we can go to liters. And from liters, we can go to milliliters. See that? So there's our path, the ounces. Why is it always too capital? That is really annoying. Okay, there we go. All right, so let's go and let's do it. I said, I'm going to insert another table just like that one. I always put extra just in case we need it, but we're just going to put it in. All right, so the first thing is what we know, which is 20.0 ounces. And now we have the conversion, which is given to us here, 32 ounces on the bottom, right? And we put 1 quart on the top. Now we need to go back to our, or we can just actually put the numbers on down here. You know, quarts is going to be down here. Liter is going to be right here. Oops, sorry, capital L. And then liter is going to be down here. And milliliter is going to be up here. Now we need to go find the equivalences. Let's find them. So we need, first we need quarts to liters. So let's go get it on our sheet that we have. There it is. Quarts to liters is equal to, that's volume, right? So we look in volume. There it is. Look, 1 quart is equal to, 1 liter is equal to 1.06 quarts. Okay, so let's go put that in. So 1 liter is equal to 1.06 quarts. There you go. And now the milliliter liter, you know, because this is the metric. So it is just 1 liter is equal to 1 times 10. I'm just going to copy this up here because it makes life easier if I do that. Come on, let me copy. Oh, it's not letting me copy. Why? It's being difficult. There we go. And I'm just going to change one thing. Makes life easier in my case. Sorry, up here. Come on, stop. Just want to put this. Oh, why is it doing this? There we go. And it's just 2/3, right? And so milliliters. Nope, it still didn't work. Okay. All that for nothing. All right, so insert. No, not insert. I want home and I want to make it 2/3. All right, and there you go. You have made it to milliliters. So now all you need to do is multiply again. There are 2 factors to multiply on both. So what I would do is I would use parentheses. I would say 20.0. First open a parentheses, then say 20.0 times 1 times 10 to the 3rd. So 1 second EE3. Then divided by, open a new parentheses, put 32 times 1.06. The other one's a 1, so we don't need that one. Equals, and I get, this is my answer right here. It's 589.62. Yeah, 62 is enough. And this would be milliliters, right? Okay, but we had only 3 sig figs from the beginning. So the answer, it would become 590. Now this is a problem because 590, oops, not megaliters, milliliters. it's a problem because that only has two sig figs, so we cannot express it like this. But if we do this, yes, we can, right? So sometimes your answer does have to be in scientific notation. It's just the way it works. Why? It's because of the sig figs. So this one needs to be like that. Come on, I just put you up. All right, there you go. That's why that example is here, so that you realize that sometimes, because you had to make that 6 increase that 9, and that 9 goes to 10, and then that 8 goes to 9, therefore you got 590. And 590 is not 3 sig figs, it's only 2. And if you put 590.0, then you have 4, so you can't have that either. Therefore, the only solution is to give the answer in scientific notation. Okay. All right, let's do the path for this one. This one's more something that you would see. Okay, you notice it says 1 serving of Jell-O instant pudding requires 28 grams of mix. Each box contains 170 grams of mix. How many boxes are required to save 15 people? So that's what we need to know, is 15 servings. We're assuming there's 1 servings per person, right? So that's what we know. That's the first thing. So servings, we're going from servings. We're going to go to grams, right? Because you notice that each serving has 28 grams, so grams. Then from grams, we're going to go to the next one. Grams is connected to box, right? And box is connected to nothing, because that's where we need to end up. So there you go. There's your whole pathway. Okay, so let's go. Let's insert that table and go. Oops, did I insert it in the wrong place? Apparently I did, because it went away. No, yep, I did. I put it in the wrong place. Okay, undo first. Sorry. I need to do it on the right spot. I thought I had it in the right spot, but I did not. Okay, now we go. Now we're going. Insert the table. There we go. All right, so we're starting with what we know. We know that we need 15 servings, right? Servings, okay. And the next thing that we know is that servings needs to be on the bottom, right? And that grams is the next connection. That's what we made the path. Needs to be here. And then we know that grams now needs to be down here. And box needs to be up here. Okay, so now we go and connect it. 15 servings. It says 28 grams. You see that? Per 1 serving. And then it says there are 107 grams in 1 box. I don't know why it's not listening to me. There we go. All right. So now we can just multiply and divide. So it's 15 times 28.0 equal, and then divided by 107. And I get 3.928, no, 25. So 3.93 boxes. But the problem here is this has to be a whole number. Why? Can you buy 3.93 boxes? No. So in this case, since servings is a number that cannot be less than, well, you can put half a serving, of course, but boxes you cannot buy less than 1, so you have to buy 4, right? And that is how you do this one. This one doesn't matter. This one doesn't have sig figs. It has a limited amount. Okay. All right, let's go to the next one. Now this one, you know, we're going to skip number 34. Yeah. I mean, you can look at it and you can tell. Okay, so the actual pencil was 15.85 centimeters. All the students measured totally wrong. I mean, obviously they're not accurate, but they're very precise because there's not but 1.01 difference between their measurements. So, okay, now let's look at this temperature. What would you say that is? Okay, looking at it, you can see that there are 5 little marks, tick marks, between 0 and 10. That means each one of those is 2. So you can measure 2, 4, 6, and then there's a little bit above the 7. So 7.2, let's say. And that would be degrees Celsius, right? So degrees, sorry, yeah, Celsius. I'm just gonna, all right. Now, show the correct number of significant figures in parentheses. That would be 2. Why only 2? Because we could really only measure the 7 accurately. The 0.2, that's me saying that's a little higher than half, you know, so that's what is known as your uncertain digit. All right, so let's do the next one. The next one is this one on the bottom. It says, what is the length of the pencil shown in the image? Okay, so if we actually take a line, and I'm going to try to make a straight line. Don't laugh at me because it's hard. It really is hard to make a straight line with this thing. Okay. There. Okay, so that's about right, right? It's not quite 16, is it? So we can actually measure 15. So we're going to put down our answer as 15 here. Point what? I'd say 0.9, right? I mean, that is so close. All right. And that would be, it says centimeters. Okay. So we could measure the 15 accurately for sure, but the 16 is too few. So we cannot say 16, but it's close to 16. So 15.9 is as close as we can get. So how many sig figs are there in this measurement? 3. Is there an uncertain digit? Yes, there is. Which one is it? The 0.9, right? The 0.9. The 0.9. Let's just say 0.9. Okay, so the last one, obviously. All right, so that's what that one's asking. Now explain what an uncertain digit is in measurement. Well, in this case, it's the last number or digit, if you want to call it. Ooh, what in the world? Where's the L? It's like I can't type today. The last digit. Okay. Come on. Digit in a measurement that cannot be measured, so it is estimated. Therefore, the name uncertain. You see? What is that? Cannot be. Okay, I don't know where these M's are coming from, but they're annoying me. Okay. All right. So what type of measurement? All right. You notice you have density, length, mass, time, and volume. Okay. So number 1 is what? You can put it on the chat if you want. That is D, right? Density. Yes. Number 2 is time. Obviously, it's seconds. Kilometers is length. Grams is mass. Centimeter cube is going to be volume. Millimeters is length. Milligrams is mass. Length is volume. And grams per centimeter cube, again, is density. Density is what is known as a derived unit because it derives from two other units. And those units are grams in milliliters or grams in centimeter cube in this case. And then the last one's a matching that you can do yourselves. Okay, 40 we're skipping. This one is the last one that we have here. We're going to do the sig figs. So 5 for the first one. 3, right? 4. 4. Man, I gotta count those. 2, 4, 6, 8, 10, 12, 15. 15. 1. And actually 3. All right. And this last one, I want you guys to figure out what you would do based on, and that's milliliters. I don't know why it always takes that off. Okay, so figure it out. And we'll look at it when I see you again Wednesday. You figure it out. Just insert your little table like I do. It helps you with dimensional analysis. I'm just going to insert a 4 by 2 by 4. Yeah, it's good enough, I think. If not, you can always add. And I'm going to give you the very first thing, which is 1.0 quarts. And now you're just going to make your path. Okay. You have to get 2 pounds, right? So your starting point is 1 quart. And your ending is pounds. Anyway, we're done. So I will see you Wednesday. Take care. Enjoy your one day off. Bye-bye. I'll be posting this lecture later on.